So
Okay.
let's discuss about the PoN off-chain part. Subhash, do you want to take it forward?
Yeah, sure. Yeah, so as we said, like there are multiple parties involved in the PON, like relay, builder, reporter, and proposer. And on top, for proposer has like this MEV boost thing that works as his personal assistant, where it gets everything. So we now the thing is, how do we set up this whole infrastructure? Of course, the assumption is that you already have gone to like the dApp, our PON relay dApp, and you have already registered yourself. Let's say you want to set up a builder, you have registered your address as a builder. If you want to set up a proposer, you have already registered yourself as a proposer. So it's like the based on that assumption, yeah, this is the dApp. Um,
Yes. Yeah. So is it that? Cool.
yes, this is the tab. You can register here like as a proposer, as a reporter, as a builder. You connect your
Proposer.
wallet, yeah, reporter.
This, this is a connect wallet screen and then register. So reporter just register with the ECDC address, correct?
Yes, correct.
Right. And the builder just register with just like also ECDC address. So just to clarify this point, the builder can only have like one builder registered to one ECDC address.
Yeah, actually, it's like a one-to-one mapping where every wallet we have one builder
What
instance.
I saw something
Mhm.
on the builder. What it said deposit collateral.
Right. Yes. So the thing is, okay, yeah, it's an interesting thing. So we know the whole MVV supply. It is currently kind of skewed. I mean, it's believed it's built on a simple thing called trust, but we all know like you should never trust like someone behind like hex decimal string. You cannot trust anyone. Everyone is just behind their ECDS address. So we are like we can't do that. We can't just simply say that, oh, the builder will never grief you. It's true that the relayers have kind of introduced this additional layer after the merge where it's difficult to get skewed, but I mean, it's difficult to like the builder cannot get away with doing something wrong. But the thing is, there also the relayer needs to know everything, and our whole motive is that it's proof of neutrality. No one should see what's inside the block. So what we do is like the builder, it needs to give some collateral that is kept with us. The builder just goes on doing its duties. In case, I mean, God forbid, someday it does something wrong, either like I mean, it may want to like do something wrong, or it may be possible that for some reason their infrastructure was done down, and that's where, in order to pay the proposers the money that they deserve, we use this collateralized ETH, and from there we pay the proposers. So it's like a proof of stake only, where you're staking something. You do good things, you do your duty, you will get rewards. You don't do your duty, you will get slashed, and that's why the good.
Wait. So builder will never show what is in the block to anyone. That means it's an encrypted mempool. Like that basically it gives the builder is basically tell the relayer, I want to make a block with the validator at a slot number in a consensus layer. Is that at a proposer? Would it tell the proposer how this actually happened?
Yeah, that's a good question. So the thing is, we have this river, like a very huge river, like that is consensus layer. It just keeps flowing ahead and ahead. The water keeps flowing, and let's say every 12 miles, we reach a new like stoppage. We reach a new like port every 12 miles, and every port has a dedicated owner, and this owner is decided like as a lottery. I mean, you know, like it's like a random thing, and the owner is decided for the like port. Now the question is, you are sending some stuff to the like you are sending some mail, you are sending some letters to this port to the owner, and you're the boat which carries this letter. And before, like in 1800s, there used to be a thing called postcards. They were like open letters where the postman could read your letters. They could see what you have written. And that was like, that was like really difficult. You can never send anything private.
Yeah, so you get this kind of postcard and everyone can read it, but it's actually ultimately
Exactly.
it comes into the possession. That's really nice.
Yeah,
That's what's
right.
that's what's happening now. Like
Public
Yeah,
mempool.
everyone.
that's exactly. So this, like, ports are like the slots. Every 12 mile we have a new slot. The Ethereum layer keeps choosing a new owner, a new proposer for the slot. He has the complete authority of the slot. He can propose any block he wants, given that of course it's a valid block. And there are this all the searchers out there that want to send their letters to the the owner, that hey, take my letters and just dump it in the chain. But the thing is, me being the boatman, I am the relay. I can read all these postcards currently. So yeah. So the thing is, we say, hey, this shouldn't be the case. Let's put your postcard inside an envelope. Let's seal this envelope with a cryptographic scheme. Let's give this letter to the port owner. If something goes wrong, we have the cryptographic proofs. We can always open this seal. We have the proof of this seal, and we can always check the transactions to see, hey, if that there was a, like, everything's correct or not. And if, let's say I am like let's say you send me a letter to you send me a letter. You are a builder. I am the port owner. You give me a letter that is not valid. It's invalid. And when I try to give it to submit it to the beacon chain just tells me, hey, it's invalid. You are doing something wrong. And that as a port owner, I have been selected for that slot. Yeah, I have missed my opportunity, right? It was my opportunity. I get, like, hardly I get five slot opportunities in a year. The consensus layer selects a proposer for only 5 times in a year. And here I am, I missed one opportunity. So there we just take the money from the builder and we pay the proposer. So this is the whole flow.
So the way, like this, I mean, this is very cool. The way that you're explaining Ethereum current system is 1800 postcards. We want to upgrade to an encrypted email that you can hire Gmail or any other client that to send and receive email, but only the user who actually destined to receive that email, and the sender and receiver can actually read the content. But in between, you will have multiple servers helping to do that. You could have a client software that is actually, that's what you do, right? So they will not be able to read the content. And similarly, the builder is the sender, the email, the analogy here. They know, they actually know whom you need to send it, and then the other party can actually know that, oh, this is actually routing to the Ethereum execution layer, and they will sign it, and they also see that one of that instruction is for me, and then the proposer can actually see it. So you show some of the information where this letter is going as per your analogy, so it will never end up in a different country.
Right.
Okay, cool,
Absolutely.
cool. Okay.
Yeah. And yeah, like, even if you want to send a letter like, hey, there is like 1,000 kilograms of gold buried under this, like, location, only the person will know, not me. And that is, of course, like, that's what happening. There's more money than 10,000 kgs of gold currently in MEV. So you never want to show that to a dealer.
I will make it more civilized. If you want to send an email with your account details of the bank, it is much easier to send it in encrypted fashion because you don't want everyone to see it, right? Get doxxed.
Yeah, definitely. Yeah. And that's what we are trying.
Cool. All right, cool.
Yeah, so that's where the whole concept of collateralized ETH comes in. That's where the concept of RPBS comes in, that we will that we will take a deep dive a bit later when we go through the actual software. But yeah, that's pretty much like how exactly we want to do it, like with using these cryptographic schemes, using these multiple parties, multiple servers, clients. We just want to make a secure channel of communication between builders and the proposers that in true sense, establishes the proposer-builder separation.
So we are only discussing about the proof of neutrality relayer part now here. We're not talking about the PBS and the payouts and everything, right? That's completely a different system. That's an on-chain contract. Here, what we're talking, the off-chain part, how you're basically making sure this proof of neutrality is ensured, but at the same time, how do you get this coordination work seamlessly?
Correct. Yes, exactly. Yeah.
Okay.
Yeah, let's get started then with like how to set up the software, which is the most important part.
Let's see.
Um, yeah, let me share my screen.
I got my
It says
M&M
it's
ready.
okay.
That's an internal joke.
Okay, and once we have, yeah, now yeah, maybe the first step is let's get through, let's go through the relay, the, the devil here. Let's get through the relay and let's see how we can set up a relay. Yeah, so technically, like you can run a relay in any computer that runs like a Golang code, but the thing is, it's like a somewhat resource intensive task, because at the same time you are catering to like hundreds of builders who can send multiple blocks, and there are a lot of like complexities. So it's always like a good practice to set up your PoN relay in a like a i mean like a good system, like a maybe a EC2 instance, like a Azure cloud, anywhere you like. But the thing is that, yeah, the relay should have like a good quality of service. It should always have a good uptime, because it's the core of your PoN system. If this only goes down, your whole system is wrecked. You will earn nothing. So
Wait,
and
wait,
also
wait,
it's
wait, 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 wait. So when you say the relayer is a core system, a builder still can do P2P, right? With the proposer, if they want to.
yeah, technically they can do if P2P thing if they want, but the thing is, when as a proposer, it's fine from builder side. Builder can do anything they want, but for a proposer, when they sign into PoN, they get like they sign in themselves to this smoothing pool, where the thing is, our contract in current MEV, let's say you get a block, you get the MEV and you are paid directly. But as we have seen, the chances of getting a block are very less. You get like 5 blocks. If you are like in 50th percentile of luck, you get like 5 blocks in a year. And you have to like wait for like, let's say, we have seen validators that have been active since March, which has been like 7-8 months, and they haven't received a single block proposal yet. So
No
yeah,
payouts,
that is the
right?
condition.
So
No payout,
no,
yes.
no block, no payouts.
No blocks, no payout, exactly. Yeah, they are stuck there with this consensus layer reward of like 4% and something. They could have gone for government bonds, but yeah, like that's the issue
No,
here.
Stakehouse is still better. The Fed has about 5%. We're still 5.2%. So we're still
Exactly,
better.
yes. Yeah, definitely. Yeah. And but yeah, like the thing is, but we want to like enhance that with like PON. We want to take that 5.2 to like 8.7. We want to compete with the great execution layer rewards. We have seen people getting 700 ETH as MEV rewards, right? So what we do is like we have a smoothing pool. During a duration, let's say a duration of 7 days, the smoothing pool works. We just keep collecting MEV rewards for all the blocks within that duration, and at the end of the pool, at the end of the cycle, we just distribute the rewards among all the participants. So that being said, if you are uh, if you're taking part in if you're taking part in PON, you are committing your 100% bandwidth. By 100% bandwidth, I mean you are committing all your block proposal opportunities to PON, because your payment needs to go to this smoothing pool, so that at the end of the day, everyone can get a share of the pie. and you will also of course get the share of others pie as well. But that's why if you're going P2P, that's fine by us, you can of course do that. But the thing is, um, for the reporter not to report you as a defaulter, by defaulter I mean someone who commits themselves to the PON but doesn't take up a PON block or doesn't pay the PON smoothing pool, you must include a transaction in your block that pays the smoothing pool. um, so the thing is, you can go P2P, that's fine by us, but your payment should be always towards the smoothing pool, and you should always cooperate, and otherwise that's a slashing.
So
So
it's a
it's like more.
yeah.
Go on, Matt. Go on.
No, go on.
I was just going to say, it feels more expert. You've got to be more careful, right? You've got to make sure that you configure your system more correctly and do the payments to the payout pool correctly, or otherwise you're going to have trouble.
Yeah, right. And I mean, hey man, we have a great system as a relay here, PON relay. We can't see your transactions. Just go through the relay. I mean, we will do the check for you. Yeah.
Right.
So yeah, that's like the whole P2P thing.
So
how they
on the relayer part, you said it's kind of a little resource intensive. Do you give us a little context into current relayers in the flashbots construction? How do you compare between the relayer PON relayer and the flashbot relayer, and how beefy is ours, or is that the existing relayer model?
Oh yeah, definitely. So from our discussion till now, two things are clear. There are two things that are crystal clear. You don't register through the relayer, you register through the dApp, and you don't give the transactions, the execution payload that we say. I mean, what we call execution, you don't give it. And technically, those two are the biggest, they have the biggest share of storage consumption in a relay, because for every slot, every block bid, you need to store the execution payload, a bunch of transactions. Those are like a lot of bytes and everything. And you also at any given point of time need to maintain the registrations of validators. For us, that is the blockchain. The blockchain is storing all the registrations for us, so that we are making use of this big database, Ethereum. And that's why there we can reduce the storage consumption. And also we don't need to store the transactions, a bunch of transactions like for a block, and again we save a lot of storage out there. So you can, we are still, the thing is, you cannot definitely give a concrete number on what like current relays need, but based on the assumptions of, let's say you need a AWS instance that can have like 8 GB of RAM and those kind of things, we can easily say that at least on storage front, we are 50 to 75% better than the existing systems when it comes to storage consumption.
Right. Let's begin. What is it?
Yeah. Let me just one second. Yeah. So the first thing, of course, we want to set up a relay. So yeah, so we will first I will SSH into a EC2 instance that I have set up, so that I can run my basically the PON relay system. Also, just for context, we have this great documentation out there that can give you like a step-by-step guide of the whole process. So this is the relay guide, what you need to do to run the relay service. Guys sneeze. Yeah, so now the first step, of course, is to you need to run a RPBS service. What is RPBS? It stands for restrictive partially blind signature. It's a cryptographic scheme. As the name says, it's restrictive and partially blind. So we perform this whole scheme in two different steps. And without going much deep into it, on a brief level, it basically maintains the authenticity of the payment that a builder needs to do to the payout pool. The payout pool is technically, I mean, the thing is, a builder will give a block to the relayer, and the builder will set his address as the like recipient of all the EIP 1559 rewards, and in turn the builder will basically pay a amount to the relayer, and sorry, pay a amount to the proposer, and in to pay the proposer, it basically pays the payout pool, which is our like smoothing pool. And to make sure that this payment is made without like exposing the actual payment information and everything, we take help of this RPB scheme. To give you just context of it, we just have a builder here. Builder sends the like bid and all the transaction bytes in the sense that transaction bytes for the only transaction byte that it needs to send is the one where it is paying the payout pool from builder's wallet to payout payout pool. It will send the transaction bytes and the bid. In response, the relay will go to the RTBS service, it create a commitment of the payment. It will send back the commitment to the builder. Later on, this commitment is used by the reporters or the hosted service in part 2 to create a challenge, and the relay has to solve the challenge to prove that, okay, the builder had actually paid me. I mean, we are just saying the builder can do something wrong, but hey, the relay can also go wrong, right? So the relay also needs to prove that actually there was a proof of payment. We can't just say from thin air that, hey, he had promised me to pay. So the relay will prove solve this challenge, and that's how the hosted service will know, okay, there was a promise of payment, the builder didn't pay, the relay can prove that there was a promise, and now we will slash the builder, we will take money from the builder and pay the payout pool. So that's why we use this RPBS scheme. So to run the like RPBS scheme, the first step is, it's a part of like, it's a Docker image that we have for you. You can run it on any, like we have tested it on multiple systems, you can try it out. First step is, of course, we will pull the Docker image. Yes, good thing we already have the Docker image in our machine, and we will simply run the Docker system. It's like a service it's a microservice that runs on port 3000. So you just need to make sure that you have nothing else running on that port. So we will simply do sudo docker. Yeah, and you can see RPBS service running on port 3000, and you have to do nothing else for RPBS. The system will handle everything. So now we just we will put this service on background. Now we will go to yes. Okay. So one more thing that you need to do is you need to basically yes. Okay. So the thing is, we have a PoN relay in form of a GitHub repository. Just pull that repository. I mean, maybe you pull that, maybe you've FTP that into the server. And what you need to do is like, you just first steps, you need to run a database instance and like a Redis instance, the like Redis for caching and Postgres SQL for database. You can of course run that. I mean, it's a standard Postgres and Redis, nothing from our end. So you can always technically run it like with whatever commands you want. Like you can say docker run like Postgres user and everything. We also provide a Docker compose file. So you can, what you can do is like simply just type sudo. I mean, of course, you need to have your Docker compose installed, and you just need to do Docker compose up within the repository, and boom, your Redis, and both your Redis and your Docker will be and your Postgres will be available. The Postgres server also comes with an admin service. You can go into the admin service and you can see your data tables and all if you want. But yeah, that's how it works. We won't do it because we already have the service running on our system. We already have blocks being stored and everything. But yeah, we have already set up the Docker Compose for that. The next step. Yes. So, yes. Yeah. So, okay. Now coming to the next step, so the relay needs a consensus client to function properly. Why it needs this? Because it relies on consensus client for information like whether a validator is valid or not, what's the slot, what's the like block hash and everything. So for all the validation purposes, it's a consensus client. But hey, you don't need to run a consensus client. Don't worry. What you can do is like you can use any existing consensus client, and every consensus client, any implementation, let it be Lighthouse, Prism, anything, it comes with a standard Beacon API implementation. It's a part of the spec. These are like bunch of API endpoints that are available with your consensus client, and we just we make use of that only. You can use any API endpoint of there, and yeah, you can make use of any API endpoint, and you can use that to get the information. You don't need to run a consensus client of your own. So it's similar to how we use like a provider in like execution layer. So what you need to do is like you need to create a tunnel from your localhost port 3500 to the beacon nodes port where the API is exposed. So the thing is, this is different for all the nodes. Lighthouse has 5200, Prism has 3500. All this like API endpoint, API server is running on different ports for different clients. So you just need to go to the client's website. You will see the port where it's running, and just come and just create a SSH tunnel. It's simple. It's just you need to run right like. Yes, you can see, right? For me, it's just showing like the Zoom panel.
Yeah, all good. I can see it. Yeah, you're creating a tunnel from 3500 to localhost 5052. So it's as if the
Yes.
validator's on your machine, right?
Yep, exactly. So we are just creating a tunnel to our port 3500, and yeah, great. We have the service running. Yeah. Now we will. So this is the second service that you need to run for your PoN relay to work. Now the third service, we will quickly create a go to a new screen. I mean, you need to keep everything running in the background. You need to make sure everything is running on the background. Yeah, so we will go there. We will go inside our repository, like the function and everything, and we need to run a command. Yep, go run like you need to run a housekeeper service. Now, what is housekeeper? I mean, it's like we haven't created it ourselves. This is a concept widely being used in the current implementations of Relay. So we have just taken help of it. Like the housekeeper basically is a service that keeps working on the background, cleaning up stuff, putting in new stuff. So let's say what are the active validators in the Ethereum network. It just fetches that, stores that. Let's say there are some data that we keep storing on Redis, on cache, on database, slot by slot. Every time the slot passes, it just keeps cleans that. It also every time a slot comes, it goes to the chain to get the previous random, because previous random is something that links the execution layer and beacon chain. that comes out in the difficulty field currently. So it just does all the background stuff that is needed, essential for your system to keep going, and that's why housekeeper. And it's a great implementation in the current system, and we just made the use of that. You just need to run that, and you need to link your database. If you had followed our
Where is this housekeeper system comes from? Is it our own system or is it part of the Ethereum package?
It's this is part of current relay implementation.
Right.
We have made some small changes, but we are widely relying on what they are doing.
Okay, cool.
Yeah. So as you can see, it just keeps moving. Updated head slot to 5263085, and every slot it moves the head slot. Every epoch it cleans up stuff. Every slot it gets the previous run. Those kind of stuff it just keeps doing in the background quietly, and yeah. Yeah, so now we have our housekeeper service running. We sent it to a background. Now we will need to run the most important thing, the relay API. Basically the whole relay service. Ronnie, can you make sure the builder is turned off so that, the logs just don't get bombarded?
Yeah, it's off.
Okay. So in order to run your relay, you basically need to provide, you just need to run it as a Go package. Really important thing to note here is that the whole relay system is based on Golang. You need to have the Golang latest version installed. We are currently testing it on 1.2.0, and also in case your Golang, some packages doesn't work, you need to, especially in case of builder, we have a troubleshoot guide here, and you can go there and you can just check what are the error codes to match basically what are the possible conditions. But
Well, where is this troubleshoot guide?
We have written a Google Doc, but we will need to link it to the our docs only.
It will be available on the docs, right?
Yes. So these are all the things that we faced, and from we have seen how it can be tackled. Yeah, especially we have seen that most of the packages that are being built as a wrapper on top of C programs gives error for some machines. So we have some specific export conditions, like you need to export CGO flags and everything. So those you can refer there if you get an error for some certain packages like BLST and all. So just that's just a heads up. But yeah, apart from that, to run the system, you just need to run API. You need to specify network. Currently, we are supporting Gorilla and mainnet only. Maybe in future we can support other testnets, but currently you need to put anything of Gorilla or mainnet. You need to provide a secret key, which is a BLS secret key that will technically create the signatures that the proposer needs to validate. So yeah, of course, give us a good secret key. We are using a dummy one, and yeah, that's how the system works. And yeah, once you enter, yeah, as you can see, block builder API enabled. All the APIs are enabled one by one. We connect to the database, connect to the data store, connect to the Redis. We set up the validator processes and everything. And yeah, the system has started. It's just ready to receive blocks, ready to receive requests from proposer, ready to receive requests from reporter, ready to receive requests from builder, and it's just ready. And we will just send it back to the background. Just to test it's working fine, we will just do a curl localhost. Yes, as you can see, we are running it on the system runs on port 9062, and as we curl, you can see the PoN Relay API, it's working fine. It gives us PoN Relay API. But yeah, now the next part is, this is an infra thing you need to do. So as you can see, it is running on port 9062. Let's say you are running on a private instance like a EC2 and all. You need to expose this port for the rest of the world to use, because builder will be running somewhere else. the proposer will be running somewhere else. They need to access it. So just yeah, so just like you can use any web server, you can you can use any Nginx kind of thing, and just enable this port for anyone to use. And maybe you can have some cool DNS on top of it, like, and you can just share it to everyone. So that's how the whole relay system works. It's good to go. Maybe the second, now we need to have a look at how the builder works. Like actually, where are the blocks being built? Who are sending the blocks? So maybe Ronnie, you can take it forward with builder installation.
Okay. I would share my screen. I would go through how to install the builder, set it up, and start building blocks.
Sure.
Okay, just as the relay, all documents would be on our documentation site for PoN. We have the relay guide, the builder guide, and the proposer guide. The builder essentially is an Ethereum node you're running. You essentially need to have an execution client and a consensus client. More or less, these are the two different chains that Ethereum runs in order to speak to each other and validate blocks. So on our documents, you'd more or less need the right infrastructure for this. Just as the relay, you have a heavy point on resources because you need to be in sync with the execution block and the consensus blocks on both chains on the Ethereum. So once you have those resources, which in this case, I am using an EC2 instance from AWS, you will need to get a consensus client of your choosing. The builder software really is not a consensus client, it's a custom execution client, more or less a custom get. So you can use any consensus client of your choosing, just as the relay, we access a particular consensus endpoint just to get our information as to what block is being built, who's ready for the next block, and who's going to sign over this particular block. So for this case, we're using Prism as a test consensus client. You could reach out to the Prism installation website, which has a full explanation of how to download Prism and how to install Prism. You could use Lighthouse. There are a broad range of different consensus clients for this particular step. In this case, I would use Prism. I have a download version of Prism to start off. After downloading Prism, you'd have to install it correctly on your instance, on your server, on your remote server, on your cloud server. So I have an instance of my cloud server over here. If I check the logs, I have a copy of Prism here. You could transfer by Git pulling, however you'd like to put the file onto the server. These files are more or less from GitHub. You could download the entire Prism folder and install it and transfer onto your server. You could use FTTP, SSH, file transfer, any option of your choosing. Following the instructions to install Prism, you more or less need a consensus folder. You can name it as you wish, and then transfer all the Prism files into that particular folder. Following suit, I have done that correctly. I've transferred all the following files into my Prism Develop Boost or Prism Develop, any folder you'd like to name it. These are a bunch of different options. It does not really define the client to be used. These are the Prism files from GitHub, and following what Prism instructs to run GitHub, the Prism client, you'd more or less take this curl to get the client downloaded, have the file set up for execution, just really follow the Prism's exact flow, and then run your execution client and then your consensus client. You could follow suit for different consensus clients as you're choosing. So to run Prism as instructed, the repository more or less has a file called prism.sh, as you have seen, downloaded from the Prism client. You need to call the script and then pass the parameters as instructed within your consensus client. This would have your consensus client up and running. Every consensus client varies slightly differently with the kind of logs you'd see, but to verify, just check with your client and be sure that it connects to a node and then you are more or less syncing up with the Ethereum consensus blockchain, the beacon chain. Now to the builder software. This is currently waiting, as I mentioned before, as a builder, you're essentially running an Ethereum node. So your consensus client would be waiting for an execution client's software to be started up and synced with it. You could use any consensus client again, as I had mentioned. Now the builder software, likewise, the builder software would be available on our GitHub. There are instructions within the PoN builder documentation for grabbing the builder software as well to install. The builder software is built off of Geth. It's just a custom variation of Geth, just to improve your block building capabilities, but ensure that you're still in sync with the Ethereum chain, and you can still get your attestations, your fees, your block rewards, and you don't need any extra clients aside the 2 clients you usually run for an Ethereum network. So going on to the repository, this would be open and available to anyone, with releases as well, continuously updated. This is more or less a Geth implementation, as I've said. You could install by make Geth after downloading the repository, or make all packages within Geth if you're running any other client packages or any other frameworks or tooling within Geth. So going back to our EC2 instance, we more or less have an empty folder in here. I've already downloaded our Geth variation from our GitHub. You could transfer all the needed files to your instance. You could pull it as you're choosing. This will transfer all the installed files onto your instance, and you could see as it's being uploaded correctly. So you just have to wait to move your transferred files over to your instance in whatever means you're choosing to start your execution client with our builder software embedded. Just give it a little time. Shouldn't take that long. The execution client is not that heavy of a client. Most of the reason we recommend an instance or a cloud resource is because the storage of chain information gets large over time, but the clients themselves don't require that much to run. As shown here, the minimum requirements, at least 4 GB of RAM, roughly 1 TB of storage. All these are in accordance with Geth's minimum to run any execution client. Unlike the relay, in this case, I just mentioned, you don't need any other particular softwares. You don't need to, as a builder, you don't need to run RPBS. You don't need to make any changes to your ideal workflow. Whilst we wait for this to be completed, I would continue down the documentation. After installing Geth correctly, you would need to start Geth with a few flags that are side Geth's original flags as you would run. You can choose to run Geth as it is without the builder client or the builder software activated. You don't need to make any changes to re-download a different version of Geth. We ensure that the Geth package downloaded is of the official Geth standard, and then the builder software is within Geth to activate with a builder flag. It should take a few more, just a minute more, and then we would install the builder software.
So the builder will support block building from the Geth mempool and private order flows as well, right?
That is correct. So the builder software would allow block building, yes, from the mempool with Geth, just as the execution client accesses the mempool, and also would allow you to pass private transactions to the blocks you're building to be presented to the relay as well. Geth provides different ways actually to install the client, aside make, which is pretty simple for users who want more flexibility to know what exactly they're installing. You could enter the make file, which is really what make Geth does, to actually understand what is being built. So the make file, so make.geth, actually is just building this particular Geth command for you to run Geth. You could make all. There are different test cases you want to build with Geth. This is just a full workflow in detail for more in-depth developers to install particular packages or access particular files of their choosing. So once the files have been transferred, just check on your instance, everything's been moved correctly onto your instance. You must be within the directory of the Geth folder. You should ensure you're within the folder which you place your Geth in. So cd PoN builder in this case. Just double check. And then to run, you could run make. Again, I'd shown a more detailed custom way of running Geth. So we have tried the Geth installation. More or less you need Go. The minimum Go requirement is 1.2.0 due to certain type upgrades Go has. That's Geth, the new Geth client supports. So to install following this, you could run Go. So check your Go version. Ensure you're running at least 1.2.0. Then go run build ci.go. And you'd want to install static manned Geth. This will go ahead and download and install the required packages for Geth. Just change this. 1 second. Just 1 second. I just removed this. Does that make this change?
Right. So that's basically about the builder software, Ronnie.
Yes, that's correct. So 1 second. Let me transfer files correctly. I'd noticed I hadn't transferred all files. Correct. So once your files are all transferred, you could install Geth by running this command as in the README, or by running make. This should install the Geth package and all its dependencies. Once this is installed, you could run Geth by accessing command.geth to run your script as in the README. Geth is also run on its official website by that way, or for simplicity, so it's accessible any point you are within your instance. You could move the Geth executable into your user bin page, your user bin directory, so it's accessible anywhere. So I would, with sudo privileges, copy everything within the installation folder to, so I would go into the build folder, the bin is where the build occurred. Check, you should have a Geth package now built and compiled correctly. And then I would, with sudo privileges, copy to my user local bin. This should now enable me to access Geth from any point, and I could see Geth's version. So now Geth is correctly installed. With installing Geth, you more or less have the builder software installed. To run this software, I would walk you through each of the flags that are required or not required. If you need any further help, you could run Geth help. This should give you a full list of flags that Geth. These are all things that you still, as a builder or any user, still have access to, with further information and further flags for the builder software specifically. So I would run you through a few of the builder flags to set up to run your builder client. So you'd want to run Geth. So you want to run Geth as you would any other Geth client. So you'd call out Geth as we did with Geth version, the network you'd want to run, your data directory where you want to save your chain information. This is a required flag by Geth. So all the methods to run Geth are explained within our repository and also officially on the Geth website. This is an example to run a full Goerli testnet with Geth. Maybe the other configurations which will give you more autonomy over the kind of client you're running. The local host flag must be shown, and then the port which you're exposing. Shown before, the consensus layer is waiting for the execution layer to be run and set up to sync correctly, is waiting for port 8551. So that's the port we've configured here to speak to our consensus client. Now, every other flag after Geth's required flags are what are required for the builder software. So for the builder, you would have to indicate the builder flag, which would tell Geth's clients to expose an endpoint to allow block building to a PoN relay. The builder beacon endpoint, as mentioned by Subhashish, you could be choosing any external beacon client to use in this case. Probably you have a different configured client you've probably not upgraded. You could actually reach out to a remote consensus client in this case to overwrite your configured local consensus client. Then your remote relay, in this case, the PoN relay. It's of a specific structure. You have your remote relay URL, which is the URL of the relay you're intending to send blocks to. But prefixing that as a username, more or less, is the payout pool address for the remote relay. Builders require this address. This is required by the builder software. As Subhashish had mentioned, it's like a smoothing pool where all payments for blocks that have been proposed as a builder, which is you've registered with your collateral, should be made within that block. The builder secret key is your BLS secret key as a validator that you want to sign over a block that you have built, and your wallet address is the address that will be provided to the PoN relay within your payload as well, and your private key. These are test values, and you should always keep your details secret. This could be passed as environment variables as well when you're setting up your client. So having indicated all of these flags, the public access endpoint could be locally if for some instance you're running a test version with your own test version of a relay. You don't really have to expose a public URL, but this is required so the relay can return back execution payloads for you to propose and return back signatures after communicating with the relayer. Running this correctly should set up Geth, and you have everything running. This would indicate that PoN Builder service has started and will be waiting to sync up with your consensus client. The consensus client should now take a while. Initially could not connect to your execution client, should now take a while to have an initial synchronization between both clients, and then you more or less have an Ethereum node up and running with the PoN Builder software running. This is waiting for the sync to happen, after which all logs would be correct and you are all set up. Once all logs are set up, you should see no more errors. All other informations will be information for debugging purposes, but this should no longer exist once your consensus and your execution clients are correctly in sync. Again, there's a reason to run these on AWS instances or any other cloud resource instance you have, or any other physical service you have, because the chains download information which grow exponentially with time. Should take roughly a minute, and both chains should have synced up by then. So your consensus client is now synced up and is correctly with the head of the chain. Once this is done, your execution client should be syncing to your consensus client to meet the head of the chain. Once this is done correctly, you can see there are no more errors to wait for the sync, and more or less your builder software is all set up. I would hand it over back to Subhashish to walk you through the other softwares, or if there are any interesting bits of the builder you'd like to know about.
Yeah, I mean, yeah, that looks good, Ronnie. So, Ronnie, as I understand, like you just run the builder and you are good to go, right? Like even if you don't have any searches, the builder will create blocks for you and they will send it to PoN Relay, right?
Yes, that's correct. So once you have the builder up and running, you could access the builder by an exposed endpoint. So in configuring the builder, in configuring the builder, the endpoint you exposed was that. So your listening address is more or less the endpoint that you exposed to access the builder. Just as the relay, you could curl to this endpoint and then receive your data payload. But if you do have your server set up to be externally accessible, you could access this particular port that you've set up remotely to send in your bits as a payload. I would show an example here. In this case, we have a sample of this instance set up on builder.oxblockswap.com that accesses this particular port we have the builder running on. And you could send in your bits for a particular slot, a particular bid amount, 1,000, and who you'd want to receive the fees for the block. This is different from the payout pool transactions we had spoken before, which you must pay to the payout pool address, but there's no change in your workflow because this is automatically added to the block once you're placing a bid for this particular bid amount. So I would give an example. If I send this through, this went straight to the relay, to the builder software, and is indicating the slot I'm intending to build for is passed. So the next available slot is this. So I could, let's bid for slot. This puts in a bid for the given slot, and you have your payload ready. So you have the block that was built by Geth from the mempool, the block hash, the execution payload information. All information required to place your bid has been sent through to the relay, and the relay should have your bid for this particular slot built from the mempool for this bid amount.
Okay, makes sense. Yeah, that's great.
So sorry, just to double check, bid amount is a way value, is it? Yeah.
Yes, bid amount is a way value.
Okay. Okay. So it's highly configurable. I can supply a list of transactions. I can specify explicitly I don't want the mempool to build a block. It's there's all kind of combinations that are possible here. We've seen people like I'm sure there was an NFT transaction that took up the 30 million block space allowance post merge. They just got a transaction in that used up all the block space. It's like a post merge NFT sort of thing. So people might use this in all sorts of ways.
Yes, that's correct.
How
so
are you
could
encoding the transactions for that list? Like how would they use a get client to make the list?
So the transactions passed within this list are bytes. They must conform to Get standard. So Get has packages you could import and not have to run the entire Get. So this makes passing a list on transactions available to anybody who's able to provide the bytes of the transactions to the client. It's somewhat similar to this transaction byte for this payout pool transaction. You will get information of what transaction came back out. You could decode these bytes to know the to, the from, the nonce, the accounts this is sending from. Likewise, you could also provide a similar transaction bytes to this transaction array, and an array of unlimited value count. But you must keep in mind that the transactions gas must be within the block limit. You would be notified of this if this exceeds and fails in building your block, but then you can provide these bytes when sending in a bid. These transactions would be prioritized when building the block, since you provided them, and then still add your payout pool transaction after building for the mempool, whether this is set to true or false.
Yeah, makes sense. Makes sense to me. Suggested fee recipients. So tell me about that. That's the payout pool?
So the suggested fee recipients, although you're paying a given a bid amount to the smoothing pool as a builder does onto PoN, you can still reap the rewards of your own block. So your own provided transactions of known value, transactions of known value from the mempool, you could provide your own given address to receive the value from the given block, but just ensure that you pay the bid amount, which is handled within the builder software to the payout pool.
Right.
So this can be any address you're choosing.
So, but if you wanted to, you could give all the block rewards to the payout pool, right? So you can give your bid amount plus whatever the block reward,
That is correct. This has no limitation to who you want the block rewards to go to. So you could pay the value of the block as well to the payout pool address for the particular PoN you are on.
Got it. Makes sense.
Yeah, so MEV Boost, yeah, since it's like widely distributed as software MEV Boost, everyone is using it. We are also distributing the Flashbots implementation of MEV Boost only so that the validators don't need to change much, because validators, sometimes they can be solo stakers, home stakers, and we don't want them to go through the hassle of deploying new systems. So they can simply run MEV Boost only.
So just to get some clarity here, this is just the fact that most of the validators who are the most less sophisticated actor in the supply chain currently, right? So the solo staker, when you take those kind of actors, yes, we have this kind of enterprise validators, but we are just taking that the generic version. They all use MEV Boost. We're just making it compliant to the existing supply chain last mile delivery. That's why we giving this kind of compatibility to the MEV Boost. We are not really dependent on MEV Boost in any way, right? In future.
Yeah, exactly. I mean, this is just as a stop and go measure to get more and more.
Yeah. But let's see how this works. Like at the first stage, right? We don't want them to make a lot of changes. So you just use your current. We give this kind of it's compatibility, backward compatibility, or existing scenario. Just plug and play. Use it. How do we? Let's see how this is actually going to work out. But definitely, MEV Boost can be swapped that way. If needed with any software.
Yeah, definitely, for sure. So yeah,
it's not a magic wand. MEV Boost is not a magic wand. Yeah, absolutely.
Right. So if you go to our documentation, we already mentioned how you can install MEV Boost. You have multiple ways. You can directly go to the repository and build as a Golang package. You can install their binary files. You can, if everything fails, you can just simply do what you can, simply go to the Docker. You can Docker pull the Flashbots MEV Boost latest and just Docker run Flashbots MEV Boost, and boom, you have MEV Boost running. But you need to be sure that you are running it in the same server as where you are running your client. The node, the validator, your execution layer client, your consensus layer client, wherever you're running it, just run it there only. The MEV software.
If you're a solo staker and you use like a package like dApp node and those kind of people, they already package this over for you, the MEV Boost. So you just use that standard MEV Boost and then use it. You don't really have to bother about to download all this kind of stuff.
Yeah, definitely. You have nothing different, like everything standard packages. Just mention the PoN Relay.
Yeah. Cool. So from that standpoint, if you're a dApp node user, just like any other relayer, just go and copy paste 0x block swap or any other PoN relayer that you have from the list. That's it, right?
Yes, correct.
Hopefully in the future it's automatic, right?
So you could switch it, but not this handicapped horse of MEV Boost. You really need something really actually work. a really
No,
good
this is-
utility package. Yeah.
This is, instead of boost, this is 7-day boost, right? Every 7 days you get a payout, right? So
Yes,
anyway.
that's really cool. Yeah.
Yes, yeah. So once you have installed your MEV boost, what you need to do is yeah. So I have SSH into the server where I'm running my execution client and my beacon chain client. So I will simply run this command. I will create a basically MEV boost service, system control service. I will create a file. I will mention all the like MEV boost service name and everything. And when it says relays, I just need to give all the relay URLs, the PoN relays I want to use as comma separated value. You will get this list on our PoN website. But you need to make sure that you provide the link as HTTPS. I mean, whatever it is, your public key of the relay at the relay like IP or the DNS or whatever it is, IP in most cases, like relay.0xblocks.com. And once you have it, you are good to go. Once you do this, you can simply you can simply just reload the system control. You can start the MEV boost service that we just defined and most importantly, we will just quickly check the status of our MEV boost service. And yeah, boom, you can see active running. Our MEV boost is running perfectly with the PoN relay that we provided. So now that's how MEV boost is working. But the thing is, a few clients by default, they don't come with support for MEV boost. You need to configure them to use the MEV boost builder. So we have provided kind of a list what you need to specify for like various clients like Prism Consensus, Prism Validator, Nimbus Combined, Lodestar Consensus, everything. In our case, it is a Lighthouse system. So I will just show you what you need to do in our Lighthouse executive file. Yeah, I will just open the beacon service file. Yeah. As you can see, I have just added one. This is specific to Lighthouse, just to be clear. I have added a specific flag called builder, and I have mentioned the URL HTTP localhost 127.0.0.1 This is basically the server where MEV Boost runs. It's just telling the Lighthouse to get the blocks from MEV Boost. And MEV Boost, again, if it doesn't get a block, it will build one itself. I mean, so it's just fine. It works fine. But like, yeah, that's something that you need to specify in your Lighthouse. This is different if you have different clients, of course. We have given the list what you need to do. And also for Lighthouse, also you need to do something similar for validator client. But yeah, that being said, that's all the step you need to do. You saw the MEV Boost is running and great. I mean, you just chill now. Yeah, I mean, the service is running. It's a system control service that's running in backend, and your whole network has been set up, and the MEV Boost will continue getting blocks from all these PoN relays, get the best block from you, submit it to the beacon chain, and you will get the rewards.
I don't believe it. Can you
Also.
show me? I don't believe this.
Yeah, definitely. So like, let me just quickly show you. Yeah, as you can see, our service is running. It's just waiting for a block proposal to come. Give me a block proposal, give me a block proposal. And as soon as a block proposal comes, like, hey, there is a block proposal, hey, there is a block proposal, it will just go to the relayer and it will get a block header. But I mean, we of course can't wait for the block header to come, right? Let's go and manually check a block from the relay to see how actually it looks.
All right.
I will quickly quit from this server. I will SSH into where our relay is running. So yeah, as you can see, all these like logs just going, these are like all the builders constantly sending blocks to the relay just to get their block selected. And we can maybe select any one of the blocks. We have an API response, and as you can see, boom, these are all the contents that relay will send to the MEV boost. Like you will have, most importantly, we'll have version data, everything. You will have a signature that the MEV boost needs to validate, because it needs to come from a PoN relay, of course. And most important thing is here, the value. Value basically means how much you are paying the payout pool, and that is here like 100,000 way. And the MEV boost will just use this to select a best block for the builder, best block for the proposer. And yeah, that's how the whole system will work. And yeah, I mean, everything keeps running. You just don't need to make keep making any changes. Nothing manual. Everything is automatic. Any questions, guys?
So okay, you can be all of these entities, right? You can be a builder, a proposer, a reporter, but assuming, let's say, so from a proposer perspective, I just need to use a new relayer endpoint. I just need to configure a new endpoint in my MEV boost config, and MEV boost will start talking to the relay as normal. There's it's completely compatible with that, so there's nothing for me to do. And then I just sit and wait, right? So, but I also need to be registered in the proposer registry as well, right? In order for the proposer to serve me, right? Sorry, not the proposer, the relay. And then builder, I also need to be registered in the builder registry, and I need to, well, we give out of the box software for communicating with the PoN relayer. I keep all the transactions, the block contents, the transaction list in my possession. I don't have to expose it to the relayer, but I expose like a promise of payments via the RPBS. So the restrictive partially blind signature scheme, where the block is the block contents are blinded, but it's part of the message, right, that the relay does not see. So it's like Matt said, it's the encrypted mempool. Is it Pepsi? Similar to Pepsi, Matt?
Yeah, Pepsi. It's encrypted mempool as Justin Drake proposed. Justin Drake proposing with the witness encryption, but this is a common man witness encryption. We call witness endorser. Which is a decade old. Like it's been very. It's the same way that the auctions were conducted in the Google, Facebook, and all this kind of like high throughput auctions were needed. But there are a little bit deviations here, specifically to our use case. So it is a witness endorser, using an interactive zero knowledge scheme, not non-interactive. So it's not snark. It's just a zero knowledge scheme. Yeah. So it's RPBS.
But the point is we're building on the research done, there with so we started with that base, and we want to get as close to that model, today rather than in 3 years' time, right? We want that now.
It's widely used in the industry. It's the same technique. So it basically ensure privacy for user not to get sniped in between the the actors who are not really in line with what they want to be interacted. But the builder knows it. So censoring will not be there. The bottlenecks. It's fully neutral. The user and the protocol, the supply chain actor in between the builder and a user, like in a wallet or something like that, they can basically send to the mempool. The builder knows it. Builder make the block, and they will never reveal the block content to anyone until it has been published on the blockchain. Once it is in the blockchain, it's by Ethereum default. Everything is But this is very important. Is like from this primitive of the encrypted mempools, it doesn't really limit programmability because of the PBS contract. You can do all the coordinations on the other side. So it's not just an encryption model, just blinding everything, but the whole system actually has this kind of two components. One is the coordination and aggregation, which is completely different, but giving this kind of a very and guaranteed privacy for the builder to negotiate with the proposer and with the relayer, which is the key thing that Ethereum Foundation has listed as a desideratum for that any auction need to be conducted for a PBS system, that the validator should not be able to steal if there is an XSMAV opportunity there. A relayer should not be able to censor some transactions because something there. But the builder can make that, the builder is the new entity who is actually doing this kind of transaction building process, right? The block building. They can have some jurisdiction issues. They can have their subjective rule, but there could be hundreds of builders can exist. That's very important.
Absolutely. Let's make it an open and fair market, just, put it all on chain, off-chain negotiation, on-chain settlement. Let's, this is the first step towards that.
Absolutely, yeah. So where do we get, where is the PoN in this message? Like, where is the PoN certificate? Neutrality.
Yeah, actually the thing is, builder, technically, a proposer never needs to worry about this certification and all. So it is handled by the relayer only. So the relayer will get the contents, the relayer will get the block header only without the transactions actually, and a certification will be created on information that can be recreated, from where the payment is being made, to whom is being made, what slot, and of course the transaction byte that the builder sends for that payment. And based on that, commitments and everything are created and stored on the relayer's side only for the RBS, for reporters and hosted service to fetch them when if needed. So this is something that will be never exposed to the proposer. It will be always kept on the relay side only. And the hosted service, that is something that is the trusted entity that will always verify that the cryptographically the relay can verify these payments, and then only the payments and slashings will be made. So that's the end. But if you want to see the transaction bytes and everything, Ronnie, maybe we can show the transaction bytes, right? And the commitments and everything.
Yes.
Do you want to share your screen?
Yes, a moment. Let me set up the builder software again.
Sure.
Yes. Right. So as a builder, you could automate the process of sending bids by whatever strategy or means you'd have. But for every bid you'd send, you'd get a payload with the right transaction information. So in this case, let me stop this script. In this case, I was automating the bid process because I want to get the most value for every slot. So I had a running script to send out bids for a given slot with my payload transactions. Manually, I could provide a slot to which I'm bidding for. So in this case, slot 5626385338. Let's bid for slot 3.
Ronnie, could you make your postman full screen or something? Yeah.
Oh, sorry, forgot about that. Right.
Cool. What were you saying? Sorry.
So yes, in this, as proofs, you would place a bid for a given slot. So in this case, this slot has been moved past. So I would like to bid for the next upcoming slot, which is 9, let's say 9-1, I think. Different slot now. So if that's the case, you would get the transaction bytes for the given payout. Oh, I took this out. Guys, give me 1 second. Let me put that code back in. Since initially I thought the relay is supposed to. I could just put it back in. Stop sharing. It's back for the builder. Okay. Share my screen again. Build. Then copy the Go version. Okay. So as a builder, your payload is essentially the slot you want to bid for, the bid amount, and who you'd want your free recipient to be for the given slot. The required transaction for the payout would be made within the builder software, and you would get proof as well as a builder that this transaction has been made and you have a valid committed proof that this transaction is there. So to run the builder software again, you would run geth with the given builder flags. And once your builder software is running, you could place a bid for a given slot. You can't place a bid on a slot that's passed, which has already been proposed. So you will be provided with the next available slots to bid on. Possibly 406 if we are quick enough. Apparently 405. So I'm gonna wait for 406 to place a bid on. All right, it's syncing. 1 second. I think it's synced now. This should send in my bid correctly. And additionally, you should get a signature proving that you've paid the given payout pool transaction as you have intended to. This signature is verifiable on your end as well from the relay. You could get this information just as a reporter would get this information. Additionally, there's a signature provided by your wallet address for extra proof that you created a bid, and an additional signature for security reasons with your given BLS key over the block bid as well, which is verifiable.
Okay, cool. So what about did we talk about the reporter?
I'm waiting for the cop.
Cops are coming.
Oh yeah. Yeah.
Maybe you wanna show a little bit what a reporter does and etc. If
Oh
it's
yeah, sure.
maybe the guy who's doing etc. etc. Just give us some idea before.
Oh yeah, sure. Yeah. So, reporter. So, reporter technically is like I mean, as you can see, it's like the police of the whole network. So, the thing is, we are working on a post commit architecture where after the payments have been done or after the slot has passed, we verify if the payments were made, or I mean, those kind of thing. And like we have a collateral, that's why we have collateralized money and everything, and proposers, if they do anything wrong, we just slash money from whatever they have earned already. But yeah, that being said, there needs to be some entity that keeps looking for this kind of penalties. And of course we can't trust a single entity, so we also want to distribute this. We want to distribute it into multiple softwares, multiple independent reporters. So we are providing with you this. You can run this software. If you like report a penalty, you get a incentive as well. You get basically 50% of the total money that you report. So yeah, that's a lot of money, and that's why you have incentive to run the reporters. But yeah, that being said, payout pool reporters, they ensure the credible commitment. Like if there is any PBS violation, they check all the rules. We have multiple rules to see what kind of violation is there. They make payments accordingly. You can always go through our documentation to see what are the exact penalties that a reporter looks through. And of course, anyone can run a reporter. It's like a lightweight software as well. Anyone can run it, even on your own laptop. You earn money from it. And of course, I mean, it's a first come first serve thing. Whoever first reports a penalty to the reporter, to a payout pool, he gets the rewards. So I mean, it's always good to have like a good running reporter. So yeah, that's the whole gist of reporter. And maybe this is the easiest software to run as well. This is a Python package. We will provide you with the Docker container. But if you want to build yourself without the Docker container, you can simply like first install the requirements.txt file and simply run Python main.py. And you need to provide a flag for the relay, basically which relay you want to track. I will simply give relayer.0x which is our relayer. And yeah, it says reporter started, connecting to relayer.0x.blockshop.com, ready for reporting, LFG. And it's just a simple software. It keeps looking for slots automatically. You don't need to do anything. It uses a client software, consensus client. For now, we have set up it for one consensus client only, but we will provide flags. We have the documentation for providing different URLs for flags and everything. And every slot, if there is a penalty, it will just report it.
So wait a minute. Yeah. What is right? He said it's a software that he can run it and we'll just report it. What are the configuration requirements for this kind of things to run? What is the machine you need?
Yeah, I mean, technically
you want to run by anyone, right? That's what you're saying.
Oh yeah, definitely. I mean, this for context, this currently I'm running on my own local machine. Like I'm not even using a EC2. So this doesn't store anything. It doesn't require storage. It's a simple sequential creator. I mean, you can always, we have the software out there. If you want, you can always make it like you can have like a giga version of it. But you can always run it from like a simple 4 GB RAM machine.
Yeah, so basically just like a Dropbox kind of stuff. You can just install it and leave it there. Whenever you connect it to internet, it will just connect and just look for, can I make some money from Ethereum just running the
Yeah.
software? That's actually cool.
Yeah,
Running.
true.
I think this is the first crowdsourced network intelligence for Ethereum network to keep it credibly neutral. Anyone can just simply download this and keep it in their machine. If you're telling what you're telling, it's really incredible because people can, anyone just register. It doesn't really take any money to register it, right? It's free. You only need to go to the to the dApp and register, just a simple registration. Go to the dApp and get your ECDSA address, which is your wallet address, and then register it. All good, and then run it, and it will automatically mine some money from you. If there is anyone who's cheating the network, doing not compliant with a credibly neutral thesis, right?
Yep, right.
Good, thank you. Go ahead.
Oh yeah. Yeah, but like, I mean, yeah, that's like pretty much it. The PoN reporter is the last piece. I mean, this is arguably the easiest software to run. And I mean, yeah, you just run it, you leave it. Maybe if you want to run it on a server, take a T2 micro server, keep it running, and you will, if you're successful in sending bits, you will see money in your wallet coming in from our payout pool.
Nice.
Yeah.
Go.
So yeah.
Is this LFG is part of your command, or is it? You really
Oh,
have to say LFG in the reporter?
oh, yeah, I mean, at least you have to believe that.
All right, cool. Any other questions that we have on PoN? So you go to the website. We have a website. The website, if you go to the website, you will see it. The GitHub informations will be there, right? Downloadable, where is the software will be downloadable. All the links in the documentation. Okay. All right. So we're gonna. This is going to be tested on the Girly, right? First of all.
Oh yeah, it's initially Girly. We have disabled mainnet for now.
This is post Chapella config now. So when it comes to the mainnet for Shanghai, this is completely compliant because there's a lot of changes, right? Would you want to give some sort of an insight? What are the changes like? Because there's a lot of changes on currently coming into play.
Oh yeah, definitely. I mean, post Bellatrix, this is arguably one of the largest change that we have seen on the network, and maybe for the first time we have seen the change in the block structure actually. Like we have introduced new fields like withdrawal hash, withdrawal routes. Those need to be provided by the consensus client. The consensus client maintains a global list of sweeps. It keeps calculating like 16 sweeps in a 16 withdrawals in a slot sweeps, and keeps maintaining a like list. I mean, keeps maintaining which validator needs to withdraw it, and it sends the list to get. The get uses RLP to build a withdrawal hash and those kind of thing. And also a lot of fields have changed within the block itself. So those kind of things, they are not essentially compatible with Bellatrix. I mean, that's why we have made it like a post Chapella thing. If you want to run it on Bellatrix, unfortunately it won't be like supported. I mean, the thing is, it's not backward compatible for now. It's just running on Capella.
Any other question, guys?
No, I think that's really helpful for people to get started. I'm sure there'll be more darks, more things coming along the way to help people out. This is the sort of the first release. We want much testing as possible, right? So, just like we said in East Denver, please come and, we want input, we want feedback, and we want testers. So definitely.
It's really an open, grand experiment. If things can be possibly done in a more neutral, fair, and open manner, and in compliance with what Ethereum wants to achieve in the next 3 to 5 years, we want to get it done within a few months, arguably in a few weeks.
Cool.
Cool. Thank you. All right. Bye.
Thanks, guys.
Bye, guys.